Hi everyone, glad to see you again. Today I have something informative lined up for you. If you found this video helpful, don't forget to like, share and subscribe. Stay safe online, cyber network. Before we dive into cross-site scripting, or XSS, remember, this is for education and defense, not attack. The aim is to help you understand XSS so you can protect yourself and your websites. Think of it like learning how locks work, not to break in, but to secure your own door. We'll use analogies and simple examples, not step-by-step hacking guides. Trying to exploit vulnerabilities on sites you don't own is illegal and can have serious consequences. Use this knowledge ethically to improve security, not to undermine it. Cybersecurity thrives on shared knowledge and trust. By learning about XSS, you become part of the solution, able to spot threats and build safer applications. Let's work together to make the web more secure. With that, let's get started and explore one of the web's most persistent vulnerabilities. Let's break it down. Cross-site scripting, or XSS, is a type of web vulnerability that's more common than you might think. It's a sneaky flaw that can lurk in even the most popular websites, and it's something every internet user should know about. XSS allows attackers to inject their own malicious scripts, tiny programs, directly into web pages that other people visit. These scripts can do all sorts of nasty things, from stealing your personal data to hijacking your session. Think of a website like a public notice board in a busy office building. Normally people just post simple messages, nothing dangerous, just information for others to read. But with XSS, an attacker posts a message that isn't just text. It's actually a hidden piece of code. When someone else comes along and reads that message, the code runs automatically in their browser, without them even realizing it. The website, not knowing any better, delivers this malicious code to every user who visits that page. And because the code comes from the website itself, your browser trusts it completely. XSS isn't about breaking into the website's server directly. Instead, it cleverly uses the website as a middleman, turning it into a tool to attack unsuspecting users. For example, imagine scrolling through the comments on your favorite social media site. One comment might look harmless, but it could secretly contain code that steals your login details, sends your cookies to a hacker, or even redirects you to a fake login page. The real danger is that your browser sees this code as coming from a trusted source, the website you chose to visit, so it runs the code without question. At its core, XSS is a problem of misplaced trust. Your browser is designed to trust everything it receives from a site you visit, and attackers exploit this trust to their advantage. By sneaking their own code into places like comment sections, search bars, or even contact forms, attackers can make the website do their dirty work for them. The result? The website unknowingly serves up the attacker's code, your browser runs it, and the attacker gets what they want, whether that's your data, your session, or control over your account. It's a clever and dangerous way to turn a trusted website into a weapon against its own users, often without anyone noticing until it's too late. That's why understanding this trust loophole is so important. If you know how XSS works, you can better protect yourself and help keep the web safer for everyone. So how do attackers actually sneak their code in? Let's take a closer look at the methods they use and how you can spot the warning signs. XSS, or cross-site scripting, is a sneaky and dangerous web vulnerability that comes in several forms, each with its own unique delivery method and impact on both users and websites. The first and most dangerous type is stored XSS. Here, the attacker's malicious script is actually saved on the website itself, often hidden in a comment, a user profile, or a forum post. Every single visitor who loads that infected page unknowingly runs the attacker's code in their browser, and this continues until the website owner discovers and removes the malicious content. Reflected XSS is more common, but still very dangerous. In this case, the script isn't stored on the website. Instead, it's reflected off the site through a specially crafted link. Attackers often trick users into clicking these links, maybe through a phishing email or a deceptive message. When the user clicks, the script is sent to the website and then immediately reflected back in the site's response. Your browser receives this response and runs the code, believing it's safe because it came from a trusted site. The third type, DOM-based XSS, is even subtler. Here, the attack happens entirely within your browser, manipulating the page's structure and behavior using JavaScript. The server never even sees the malicious code. It's all handled on the client side, making it harder to detect and prevent. Each type of XSS attack takes advantage of a website's failure to properly handle and sanitize user data, allowing attackers to inject their own code. Stored XSS saves unsanitized data directly to the site's database. Reflected XSS echoes it back to the user in real time, and DOM-based XSS mishandles it right in the browser, often through insecure JavaScript functions. No matter the method, the result is always the same. The attacker's code runs in your browser, with all the permissions and trust of the website you thought was safe. Understanding these different types of XSS is crucial for developers. It helps them build stronger defenses, write safer code, and protect users from these hidden threats. For everyday users, it's a reminder that not all threats are obvious. Even trusted websites can be turned against you if they aren't properly secured. XSS is all about turning trusted sites into delivery vehicles for attacks, making it a particularly insidious threat. Now let's use an analogy to make this even clearer, so you can see just how these attacks sneak in and why they're so effective. Picture a cafe with a public corkboard for messages. The owner expects harmless notes, but someone posts a fake message. Give your wallet to the barista, the manager. It looks official, so customers trust it and follow the instruction. The attacker exploited the trust in the corkboard, just like XSS exploits trust in a website. The cafe owner didn't check the note, just as some websites don't check user input. The result? Innocent people are tricked. In XSS, attackers leave a note script on a website. The site displays it, and users' browsers execute it, thinking it's safe. The attacker can steal data, redirect users, or worse, the website becomes an unwitting accomplice. This analogy shows how easily trust can be abused. Let's see why this matters to you. XSS isn't just a technical issue, it's a real threat to your online safety. Many people think of hacking as something that only happens to big companies or tech experts, but XSS can affect anyone who uses the internet. It's a vulnerability that can be exploited on any website, from social media to online banking, putting everyday users at risk. Attackers can steal your session cookie, impersonate you, and access your accounts. This means they can read your private messages, make purchases in your name, or even lock you out of your own accounts. All it takes is a single click on a malicious link or visiting a compromised page. They can create fake login forms to steal passwords or credit card info right on trusted sites. You might not even realize you're handing over sensitive information to an attacker because everything looks normal and familiar. XSS can deface websites or silently redirect you to malware. Sometimes you'll see obvious signs like a hacked homepage, but often the attack is completely hidden, quietly infecting your device or stealing your data in the background. The script runs with the same permissions as the site, accessing anything the site can. This means it can read your messages, access your files, or even change your account settings without your knowledge. It could even use your webcam or scan your network if the site allows it. Imagine your private moments or sensitive information being exposed, all because of a hidden script running in your browser. The attack is invisible. Your browser just does what it's told. You won't see any pop-ups or warnings, and you might never know your information was stolen until it's too late. The possibilities are vast, limited only by the attacker's creativity and the site's features. From stealing data to spreading more malware, attackers are always finding new ways to exploit XSS vulnerabilities. XSS turns your browser into a tool for the attacker. Your device, your accounts, and your personal information can all be used against you, often without you ever realizing it. That's why it's so dangerous. It's not just a minor bug, it's a gateway for attackers to take control and cause real harm. It's not just about code, it's about your data, your identity, and your trust. When XSS is exploited, your personal life and reputation can be put at risk, and your trust in online services can be shattered. Now let's look at the impact on businesses. XSS doesn't just affect individuals. It can damage entire organizations, leading to financial loss, legal trouble, and a damaged reputation. XSS can devastate businesses, not just users. The biggest hit is to trust and reputation. Customers may never return after an attack. Financial fallout includes regulatory fines, lawsuits, and the cost of crisis management. Data breaches can trigger expensive investigations and credit monitoring for victims. XSS can disrupt business by defacing sites or taking them offline, leading to lost revenue. Blacklisting by search engines or browsers can destroy web traffic. A vulnerable site becomes a liability, not an asset. The long-term damage can haunt a brand for years. For any online business, XSS is a serious existential threat. While developers must fix XSS, you can protect yourself too. Be cautious with links, especially in emails or messages, even from friends. If a URL looks odd, type the site address directly instead of clicking. Keep your browser and extensions updated. Outdated software is more vulnerable. Only use trusted browser extensions and remove ones you don't need. Consider script blocking tools like NoScript or uBlock Origin for extra protection. Use strong, unique passwords and enable two-factor authentication. Log out of sites when done, especially on shared computers. These habits make it much harder for attackers to succeed. A little vigilance goes a long way. For developers, preventing XSS is essential. Never trust user input, always validate and sanitize it. Output encoding is key. Display user data as plain text, not executable code. Use your framework's built-in security features. Implement a content security policy, CSP, to control what scripts can run. Regularly scan for vulnerabilities and educate your team about secure coding. Use modern, updated frameworks with built-in protections. Security is ongoing. Keep learning and improving. A strong defense is built on both technology and awareness. Make your website a fortress, not a target. To sum up, XSS lets attackers inject scripts into trusted sites targeting users. It's dangerous because it exploits trust, turning websites into weapons. The impact can be severe: stolen data, account takeovers, business losses. The root cause is treating untrusted input as safe code. Users must stay alert, avoid suspicious links, update software, use strong passwords. Developers must validate input, encode output, and use CSPs. Security is a shared responsibility. Users and developers both play a role. The digital world is always changing, and so are the threats. Stay informed, stay cautious, and keep learning. Together we can make the web safer for everyone. Thanks for watching and learning with me. Drop a comment below if you have any questions or suggestions for future videos. I value your feedback. Cyber Network.